Hello. Today we're just going to go over a quick kind of outline of what is the CDPHE Public Health Data Lakehouse and how does it work. Now, the Lakehouse has as its primary goal the collecting of data from different systems across CDPHE and primarily public health oriented systems into a single area where they can be synchronized with one another, standardized, and easily reported on using different kind of analytical tools and automations. But let's talk a little bit about how it all works. The Lakehouse is housed in the Google Cloud platform. Now, if you're not familiar with the concept of cloud computing, it's, although complex in implementation, relatively simple to grasp. If you think about your laptop or any other computer that you may have in your home, there are two key parts of it. There is the like the hardware underneath your keyboard in a laptop, right? The memory of the computer and the processor and all that kind of thing. And then there's also the keyboard and the screen that you see. So the first part is really the part that does the computation, and the other part is the element that you use to interact with it, right? But although they are tied together in one physical object in your laptop, there's really no reason that they need to be tied together. If some other machine very far away could do the same computation as your laptop does, but could communicate the results of the computation to you over the internet, that would achieve the same goal. And that is what cloud computing does. It sort of separates the user interface, the keyboard and the screen, from the actual computational machine. And now you can get economies of scale where Google owns thousands of those computational machines, and they can easily give you access to many of them quickly, and then you can remove the access quickly too. You can kind of rent those out for minutes at a time. So that's the kind of concept behind cloud computing, and the reason it's powerful because you can save money by not using computers you're not paying for computers that you're not using, and it also allows us to sort of quickly allocate resources where needed. Now let's talk about how that's set up in the Lakehouse, because there's actually a few different sets of cloud computers that we're using. So when you're accessing the Lakehouse, you start with your local machine. So this is what I've put at the top of this diagram. It's just your computer using your computer's physical hardware. Just write the things underneath your keyboard. Then you need to log into Core. So recall, Core is the system that is designed to grant access to the Lakehouse. You can access it through Google Chrome, and you log in using your username and password. Core, like many other web applications, runs in the cloud. So many of the apps on your phone, or if you're familiar with the immunization database, those are applications where they show you something on your screen, but all the computation is happening on Google's computers or maybe Amazon's computers. So Core is an application run in the Google Cloud Platform. So everything you do when you click buttons in here, that is getting run over on Google. Core has many, many different features. It has the VDI, the management to your virtual machine. It also has management of different users. Users have different access. The access governs whether they can upload files. Then there are different projects and workspaces in Core. And we'll get on into that a little bit. But the bottom line is Core is one of the computational environments, and it's used to access your own personal virtual machine. So when you're in Core, you can open your virtual machine or start it if it's not started. And over here, you can see that I just have a Windows laptop within my laptop. This one, however, runs on Google's hardware, whereas the bottom one, the main one, my local machine, runs on the hardware that's in my office right now. So this is my computational environment based in Google's platform, and that's that virtual desktop that we were talking about before. So if going back to the diagram, you can see I've just different colors for different cloud areas. So everything's in Google, but Core is running on one set of processes to run that user interface on that application. There's another set of processes that run my virtual interface. Then just to complicate things a little farther, there is a separate one, which we're calling JupyterHub. And that one is designed to allow for shared access to files and also shared scheduling of tasks and processes as a whole. So if you are inside your virtual machine, you can access that by just clicking on JupyterHub. And actually, you'll see I have it open here. So it just says JupyterHub here. This is the test version. Within JupyterHub, there are different tools, and most of them are data analytical tools. So like you'll have RStudio, Python. If there's more you want to see that you don't see, we can add them later. So you can just pop open RStudio, and now I'm running RStudio in my JupyterHub. Now JupyterHub, however, doesn't run on my virtual machine's resources. So this machine has a set of resources over at Google, and JupyterHub has its own too. But JupyterHubs are separate, and that allows JupyterHub to be a lot more flexible. It can scale up and down in a way that my personally allocated machine can't. And it's also shared by other people, so they can log in to it and use it. You can see there's, in fact, a shared set of files which mirror the shared files attached to this project in core. So that's just my quick rundown of the different environments and the way cloud computing works in the CDPHE Public Health Lakehouse. So just to recap, you access from your local machine, then there is the core web app, using one set of Google resources. There's your virtual machine using another, and through the virtual machine, you can log into JupyterHub, which uses another set of resources. Primarily, your work will likely be in JupyterHub because of its flexibility and because of the collaborative elements that it brings to the table. Thanks.